Let's consider a problem. Let's say that we have an array of size 4 with elements 1, 2, 3, and 4, and we want to insert a value, let's say 2.5, between the second and third element. How would we do this? Well, first we would have to create an array of size 5, copy over the first two elements, copy over the element we are trying to insert, and then copy over the remaining elements. This is a lot of work for a seemingly simple task, especially as the length of our array increases. This is because elements in arrays are stored continuously in memory, meaning that elements are stored one after another. To visualize this, let's pretend this is our memory. An array, or a vector, would look like this. It would just have its elements one after another. Not all containers are like this, though. For example, in a linked list, elements are still in an order, but they are not stored sequentially in memory. Instead of the next element being stored in the next slot in memory, the elements contain a pointer to the location of the next element. So for a linked list, we would still have all of our elements, but order would be maintained through pointers. Elements in a linked list are usually represented by nodes. The node struct usually has a datum value, which in our case would be a double, a pointer to the next element, and in the case of a doubly linked list, a pointer to its previous element. Now let's consider the problem we were trying to solve earlier, but using a linked list instead. So we would have 4 elements, with datum values 1, 2, 3, and 4. The previous pointer of the first element would be a pointer to null. The next pointer would be a pointer to 2. The previous pointer of the second element would be a pointer to 1. Its next pointer would be a pointer to 3. The previous pointer of the third element would be a pointer to 2. Its next pointer would be a pointer to 4. The previous pointer of 4 would be a pointer to 3, and its next pointer would be a pointer to null. Now if we wanted to insert an element, let's say 2.5, between the second and third element, we'd first have to create a new node, make its datum value 2.5, make its previous pointer a pointer to 2, and its next pointer a pointer to 3. We would also have to change the next pointer to 2 to be pointing at 2.5 instead, and we'd have to change the previous pointer of 3 to be pointing at 2.5 instead. Now let's write a function, let's call it insert to middle, to do this. Let's have it take a pointer to the prior element, which in our case would be 2, and a datum value. First, we would have to create our new node. We're using dynamic memory, so we would use the new keyword. We would have to set its datum value, which in our case would be 2.5. We would have to set its previous pointer to be pointing at 2, which is the same as our prior. We would have to set its next pointer to be pointing at 3, which is the same as the next pointer of 2 currently, so prior next. We would also have to set the next pointer of 2 to be pointing at 2.5 now. So prior next needs to equal current. And we need to set the previous pointer of 3 to be pointing at 2.5. The way that we access 3 is through the next pointer of 2.5. So current next is a pointer to 3, and its previous value needs to equal current. We have now successfully inserted an element into the middle of a linked list. Thank you.